Hi everyone, welcome to more organic chemistry. Hey, today we're going to look at naming organic molecules. And we're going to begin with alkanes and some common names. So we're looking at key concepts, Unit 1, Part 3. You can find a copy of this in Canvas. And well, title here is nomenclature, naming compounds. It's something you have to get used to. Scientists that love putting a name to everything, right? So even naming something needs a name. It's called nomenclature. Alrighty. So what we need to do in organic chemistry is be able to name organic molecules. And unfortunately, chemistry's been around a long time. There's an old traditional way of naming molecules that runs into some big problems. And then there's a more modern, systematic way of naming molecules, which is kind of bulky and cumbersome. So we kind of swap. So in this video, we're going to take care of common names. Sorry, let me get the pen, please. Okay. So we're looking at common names today. And on Canvas, there's another handout. I divided things up that just deals with common names. And that's what this video is devoted to. Later, I'll show you a systematic way of naming things. The IUPAC, International Union of Pure and Applied Chemists, that procedure, that's in the next video. Okay, so our goals, two goals. If I give you a molecule that contains an alkane and one other functional group, I want you to be able to assign a common name to it. And then we need to do the other way, the reverse. What if I draw a molecule that contains an alkane and a functional group? You see the way I feel like I'm just... Hello, welcome to more organic chemistry. I'm Dennis Gravert, and today we're going to talk about how to name organic molecules. Let's take a look at our key concepts. This is Unit 1, Part 3. You can find it on Canvas. And we're going to talk about nomenclature. Yeah, you need to get used to this. Well, if you've been around scientists for a while, you are already familiar with this. Scientists love to put new names on every idea, right? And even the idea of naming compounds needs a name. Yeah, nomenclature is a term used for naming compounds. Okay, so in this class, you need to know about two ways to name organic molecules. There's the old traditional way of doing it. I call it the common names. And there's a separate handout for that, which we will go over in a minute. That's found on Canvas too, that handout. And then in the next video, we'll talk about how to assign a systematic or more modern name to organic molecules. It can take care of a lot more molecules in an easier way. But the names you create are kind of cumbersome, kind of bulky. Those are the IUPAC names or standardized names. The common names are simpler, easier to understand for the most part. But once the molecules get pretty complicated, common names are nasty. And there's a lot of times we just can't create a common name for it. That's very clear and easily understood. So we need to know both. Let's see, here are two goals. One, you gotta be able to assign a common name to a molecule that contains, well, I'll limit it to an alkane and just one more functional group. That's all I'll ask you to do. So I'll draw a molecule on our first exam, and it'll have an alkane, and it'll have one more functional group on it, and I'll ask you to assign a name to it, and you get to pick. I'll show you a common name or a standard name, whichever one you are more comfortable with, I'll accept either one. And today I'll show you how to assign a common name. And then we want to do the other reverse, the other direction. So maybe I give you a name and ask you to draw. So I might give you a common name and you'll have to draw a structure for it. Those are our two goals. Okay, so then also on Canvas is a document that deals with common names. And the procedure, if you will, is not too complicated, just 2 steps. See if I can get the pen up there. There we go. The first step is simply to change the ane ending to YL. Okay, maybe there should be a rule 0 or step 0 here. That's step 1. What's the ane referring to? That's the step 0. So in a previous video, we talked about how you had to memorize the first 10 alkanes. So one way to do that is remember that Mabel eats peanut butter, and Mabel is M, eat is E, peanut butter, PB. That'll give you the clue you need to remember methane, ethane, propane, butane. And then you have to remember your geometric polynomials. I forget the proper term in math, but a pentagon has 5 sides, a hexagon has 6. So pentane has 5 carbons, hexane has 6 carbons, heptane, octane, nonane, and decane. Those are the 10 alkanes. That names you have to memorize. So to name a molecule, give it a common name, that is. First, figure out how many carbons there are, and remember the common name, remember the name of the alkane. I corrected myself there because methane is an accepted IUPAC name, and it's also one of the original common names. So it's both. Anyways, start with the name of the alkane, and you'll have an ane ending, methane, ethane, propane. Yeah, nice trend. Drop that ane and add YL. So then methane becomes methyl, ethane becomes ethyl, propane becomes propyl, butane, butyl, pentane, pentyl, hexane, hexyl, decane, decyl, or decyl. We'll be writing it, not pronouncing it. What we got to do after that? Okay, that just identifies how many carbons are in your molecule. You then have to follow that name, that prefix, if you will, with the name of the functional group. So here we go. Let's just look how these common names are constructed. We got CH3OH. Okay, there's one carbon here, and a name for a 1 carbon alkane is Mabel or Molly. No, sorry, I'm even stuttering on that. Trying to make a joke and not going well. 1 carbon molecule that's only an alkane is methane. Yeah, and then take off the ane ending, add the YL to make it methyl. We've identified the CH3 part. Now all we have to do is ask, what's the name of this functional group? What's OH? Ooh, so that's also the step 0. In addition to memorizing the 10 alkanes, you also need to memorize the names of the functional groups. Here's one reason why. Get all those points on the exam. The OH group is the alcohol group. So not too bad after you got things memorized, right? So 1 carbon, methyl, OH group, alcohol. There's your common name, methyl alcohol. Next one here, we got 2 carbons. Molly eats peanut butter. Eats is ethyl. Sorry, ethane. I already dropped the ane and added YL. Yeah, get some practice. It'll come pretty quickly. And then you got ethyl to identify the 2 carbons. And then the other group is NH2. Ooh, so nitrogen just singly bonded. The nitrogen's connected to carbon and no double bonded oxygen. That's an amine. So we have ethylamine. Keep going. We got a 3 carbon group. Molly eats peanut. Oh, peanut reminds me of propyl. Propane becomes propyl. And then the halide group. Yeah, you could call this a propyl halide, but then are you talking about chlorine, fluorine, iodide? No, bromine. Okay, so we're going to use bromide as part of our common name here. So propyl bromide will be fine. You can also throw in the letter N. That's kind of optional. Why? Why is the N showing up? Well, when you get the 3 carbons, you now have choices as to how you want to put that bromine on the molecule. Let's go down here. And so the process might have been, hey, I'm going to start with, you know what? Let's make that ink a little bolder, a little easier to see. Maybe I'll switch to black, right? I like the color just to highlight. different, but I also want you to be able to see it. Okay, that's a better. There we go, propane. Sorry, change it. It's looking right. There we go. Propane is CH3, CH2, CH3, or we can just draw a little sloppy at the end. We can just draw a skeletal drawing. So there's 3 carbons, so I zigzag up for 2 carbons and down for the third one. Good, got a skeletal drawing. And now, got choices. If you want to make propyl, this is propane, so I want to make propyl bromide, I can swap out one of these H's for one of these. Carbon can only bond 4 times, so if I want to add a group like bromine, I got to remove something to make room for it, right? 4 bonds of carbon. So I have the choice. I can make the CH2, CH2, CH3, and I took away the hydrogen off of the carbon off of the beginning of the molecule, so there's room for a bromine. And I was just being arbitrary. If you want to stick the bromine off to the left side, you totally can. When you're drawing it, you decide how you want to draw it. And that goes the same on the exam. When it's time for you to draw, you decide if you want to go, what is this? This is a condensed drawing. Someone else might say, no, I'm going to go skeletal. And another person will say, yeah, me too. And draw it like this. And yet another person will say, I like putting my bromine on the other side. These are all the exact same molecule. I drew the same molecule 4 times. Oops, what's that little mark on the screen? Go away. Okay, but we also could have put the bromine in the middle of the chain. So leave the hydrogen on the first carbon. Remove an H in the middle carbon to make room for a halide, the bromide. We could have had this, which is the same as this, which is the same as this. I'm not sure what else I can do. Oh, I can go sideways. Is that a good idea? I don't care. I would accept that on exam. These are 4 drawings of the same molecule, but, right, these 4, only one molecule is different from the others on the other side. They are different. And if you go in the laboratory, they react differently. They have different boiling points, melting points. They're different molecules. They should have different names. Darn it. So this is where we're into a problem with the common names, is when we have to deal with isomers. There's other problems with common names too. So this is just one problem. The procedure is change AIM to YL, add the name of the functional group. Okay, that's what the procedure is. Okay, so what do I do on the compounds on the left side here? My AIM group, this is propane. So this becomes propyl. And the name of the functional group is bromide. Good, done. Let's do it on the right side. 3 carbons in a row is peanut butter. No, propyl. Well, it's propane, and we change it to propyl. Name of that halide is bromide. And that's our procedure for naming the common names. But hey, quick, go over to the stockroom and grab some propyl bromide. You run over there, the person at the counter says, well, which one? You'll say, I don't know, Dennis didn't say. Yeah, I better let you know how to say which propyl bromide you want, because they're different. And you don't want a mixture of the 2. That's just going to complicate things. You need one or the other. Okay, so way back in the day, they said, this isn't good. 2 different molecules need 2 different names. So, hey, this first one, that's a normal way of doing it. All in a row, right? So we got 3 carbons, then a bromine, or we got 3 carbons, then a bromine. That's the same molecule. It's normally sequential, kind of straight chain. We'll name that molecule the propyl bromide. But this other one, it's got the same chemical formula, but it's a different molecule. Hey, that's an isomer. That's the definition of isomer. Why don't we just grab that little iso and throw it in the front here? Yeah. So now That's something that needs to be memorized. Anytime you have 3 carbons and it's an alkane, and you put a new functional group off of the middle carbon, that's the isopropyl group. Okay, well, maybe that's not too bad. So we got, in terms of memorizing names, we got methyl and ethyl and propyl, and now isopropyl. Let's try butyl. Okay, well, here's butane, and you might elect to draw it in a skeletal drawing. You could zigzag it in the other direction too. They're both identical. Okay, let's add bromine to this. Oh wait, Dennis, there's an isomer of butane. That's a straight chain alkane. What if I wanted a branch one? Do you really want that? Well, does nature allow that? Yeah, okay. Well then, yeah, it could be 3 carbons in a row. Think about this. And we could branch another carbon down here. Now, the middle carbon then is already making 3 bonds. So then it only has 1 hydrogen here. And you might say, well, this 3 in a row, I'd zigzag it this way and branch down like that. Or you might make it look like this. Your call. These are both 4 carbon hydrocarbons. They're alkanes. Yeah. If you want to be technical, this is the one that's called butane. And this is an isomer of butane. So what do you think its common name is? Yep, isobutane. Okay, let's just be clear. I'm not going to put that on the exam. That was just kind of fun. Ain't this fun? Oh boy, it's going to get fun. All right, so now let's stick bromine on here on a 4 carbon chain, whether it's branched or unbranched. And then let's assign a common name. That's a goal. Let's get some common names for 4 carbons with the bromine. Well, what can we draw? Well, let's start way over here with the straight chain. And maybe I decide to remove a hydrogen off the end and put the bromine on that carbon. Let's go here. So attach bromine there. And then the procedure is, hey, how many carbons do you have? 4. What's the name for that? Butane. Okay, take the ane, make it YL. So butane becomes butyl. And then what's the name of the functional group? It's a bromine. 1 done. Oh, but you know what? We could have put the bromine here. One more thing. So you're probably realizing, what about if I put the bromine at the end? Well, these 2 are the same. One's just flipped around. If you turn the computer screen backwards, you can look through the other side, they'd be identical. If you built the model, use a molecular model kit, and then just held in your hand and flipped around, they're the same. It's 4 carbons a row, and the last carbon, or the first one, depends on how you look at it, is a bromine. Those 2 are the same molecule. Another choice is put the bromine off of the middle. So either this one or this one, and it turns out you also get the same molecule either way. So I can put the bromine here, which is the same molecule. You put bromine there. That one you kind of have to rotate 180 degrees, roll it upside down. Some of you can do that in your head. Otherwise, build a model. These are the same. In our next video, I'll show you a way to more clearly see and identify that, hey, these 2 are the same. Okay, procedure says 4 carbons is butane becomes butyl. And then the functional group is bromide again. That's not so nice. That's the exact same name we had before. Yeah, we need to fix that. But in a minute. Let's keep going. 4 carbons I know it says isobutane here. Don't do that. To get the common name, you just remember the top 10 alkanes: methane, ethane, propane, butane. So butane becomes butyl. Make that a Y. That is so bad. Butyl, that's a little better. And then the functional group is going to be bromide, and I neglected to draw it. Okay, we have choices. Should I put it at the end over here? Yeah, sure, that's a possibility. How about the end over here? It's the same molecule. What about the bromine could be attached there? Still the same molecule. So those 4 carbons, I can put the bromine here, or scroll that a little bit. Where'd my mouse go? You could start off with those 4 carbons, put the bromine over here, or put the bromine down here. Those 3 are the exact same molecule. Last one. Actually, we can leave it here, can't we? Last choice, last option for putting bromine on the ring. We put in the middle carbon. Right now, that carbon's attached to 3 carbons and 1 hydrogen. So take away its one and only hydrogen, and then you can put the bromine on. And then you decide where you want to put it. Well, obviously it has to connect the middle, but do you want to shove the bromine to the left side? You want to send it to the right? You want to draw it down below? They're all the same. What is this molecule? That's butyl bromide too. No. Okay, why would you name 4 different molecules the same thing? I mean, if you had 4 kids, would you name them all George? George Foreman actually did. All of his kids, all the sons are all named George. Makes it easy to get them all to come to dinner. Okay, but most people don't do that, and chemists do not do that. So we need 4 different names for these 4 different molecules. These 4 molecules react differently. They have different properties. They need different names. Well, we go back to propyl. What do we do with that? We said, well, one was an isomer of the straight chain. Yeah, why don't we keep the same pattern and say, okay, this is the one that's going to be butyl bromide because it's all straight chain. And then sometimes, just to emphasize the point, we'll put that letter N for normal, a normal chain, kind of normally arranged. All the groups, carbon and the halide and the functional group, are all lined up end to end, no branches. That's going to be our, see that letter Y, that's going to be our N-butyl bromide, or simply just butyl bromide. So in the future, if you tell me I'm going to draw butyl bromide, I'm expecting all the atoms in a row. And then one of the other 3 is your isobutyl. But what are you going to do with the other 2? Oh man. So here's an example of where chemistry is just going to build off of itself. Let's take something we already learned and apply it here. And what we did previously, one of the things we did previously was classify the carbons. So my screen's getting pretty messy. So, whoops, that's not what I want to do. So let's change the color again. I like orange. And let's classify. So bromine, hey, what degree are you? Are you primary, secondary, tertiary, quaternary? You know what I'm talking about, right? I'm saying, are you a 1st degree, a 2nd degree, or a 3rd degree, or even a 4th degree halide? Yeah, bromine's not talking. He's kind of shy. So you got to talk to the carbon. Hey, carbon, do you know the classification for bromine? Carbon says, yeah, same as me. And I ask him, well, what degree are you? Well, let me check. I got 4 arms here. I make 4 bonds. So let's see, I'm bonding to 1 bromine. I got a carbon on my right and 2 hydrogens. Yeah, I got 1 hand on a carbon, so I'm primary. Okay, cool. You are a primary carbon, which means the shy bromine who's not talking must also be primary. Okay, I know I'm goofy. It got me through school. That's what keeps this stuff stuck in my head, is stupid little things like that. But they're fun. I like it. Hopefully it doesn't annoy you. I can keep that accent going here. But same deal. Hey, bromine, what degree are you? So that the functional group doesn't determine the degree or the classification. It's the carbon to which it's attached. So go talk to the carbon. Carbon, what degree are you? Well, this one says, okay, 4 bonds. I make a bond to bromine. There's a carbon on my left, and no on my right. That's 2 bonds to carbon. That's secondary. The 4th bond is not shown. It's to hydrogen. And so the secondary carbon has a secondary bromine. Keep going. Okay, bromine, you're not talking, so I'm going to speak to this carbon. The carbon's attached to bromine on the left, the carbon on the right, and 2 unwritten hydrogens. Wait, that's only 1 carbon. This is also primary. That's kind of interesting. This is primary over here, and now this one's primary. What degree is this halide? Talk to the carbon. This carbon has I'll introduce something else to you. What's the name of a 1 carbon group? Well, 1 carbon alkane is methane. If it's just, methane CH4, this is CH3, that's a methyl group. So you can start using these common names when you're talking about parts of a molecule too. So in this molecule that's 4 carbons, I see a methyl group here, a 2nd methyl group here, and a 3rd methyl group here. And if you don't like that, go back, hey carbon, you got 4 bonds. Yeah, I'm bonding to a carbon up on top, carbon on my left, carbon on my right, that's 3, and the 4th bond's a bromine. I'm attached to 3 carbons, I'm tertiary. I'm 3rd degree, and so is the halide. How do we do all that? Oh yeah, to construct names that are different. Well, that's not too bad. The secondary butyl bromide, let's just call it sec-butyl bromide. Not bad. So now that's a good name. So get butyl bromide, oh yeah, 4 carbons. On a secondary carbon, attach a bromine. Okay, this is the only way you can do that. You gotta get all the carbons in a row. And then off of the secondary one, put a bromine there. Cool, this is primary, let's skip that one. This is cool. Out of all these, there's only 1 tertiary halide. So let's call this tert-butyl. Tert-butyl bromide. Good name. Make butyl bromide in such a way you can get a tertiary carbon. This is the only way you can do it. Well, you draw the same molecule these 2 ways too, and put your bromine there. Now this primary one, I'm not gonna say, I'm not even gonna guess a name because it'll be wrong. It's an isomer of the butyl. So there are 2 primary halides. And so one's an isomer of the other. So this one here is your isobutyl bromide. So the Y-shaped one with the bromine off of the arm or stem of the Y, that's the isobutyl bromide. Tert-butyl is where the bromine's in the middle of 3. Sec-butyl, so it's branching off of the straight chain. And a normal butyl, or just butyl bromide, bromine at the end. Want to do pentane now? Yeah, me neither. We're not going to. Yay! So you can see clearly this is getting complicated, right? So for methyl and ethyl, those are unique. You should point at words. We're talking. Oops, went too far. Right. So there's only 1 methyl group. There's only 1 ethyl. There are 2 propyls. One's a propyl straight chain with something off the end. There's also isopropyl, a group off the middle. And there are 4 butyls. You do need to know those. And there's a lot of pentyls. And as you keep getting bigger molecules, you get more and more isomers and more common names. But not None of my tests, we won't go beyond butyl. So just to review, here we go. We do have to memorize these common names, propyl and isopropyl. A couple different ways to look at it, trying to remember the structures. You can draw them skeletal or draw them however you want. And then we have our 4 isomers of butyl. Cool. Hey, let's take a break. I'll see you in the next video, and we'll talk about systematic names or IUPAC names. Take care.